So what actually is quantum? Join me in this series to understand what quantum is like without any prior math knowledge at all. To begin with, we have a very simple definition, an old definition, but simple. It's the study of physics at the microscopic scale. Now we move to a more modern way to think about quantum mechanics, where it's the study of systems whose dynamics is governed by variables which cannot both be simultaneously observed without disturbance. Now, if that sounded too abstract, that's completely fine. We're going to simplify it down a bit further. So in simpler terms, some questions change the answer. You might be feeling confused, but in the everyday world, you can usually ask as many questions as you like without affecting the answer. For example, if I put an apple on a scale and ask how much it weighs, the apple doesn't change its weight because I asked the question. Or if I go check the time on a clock, the act of looking at what the time is, it doesn't change what the time is. You might think this is obvious, however, in quantum mechanics, it's about systems where this assumption breaks down. So why do these assumptions break down? Because when we zoom in far enough, measuring something is no longer gentle. To see or measure a very small object, we have to interact with it. And at that scale, that interaction is strong enough to change what the object is doing. In other words, at small scales, asking a question changes the answer. To make it more clear, to find out something about an object, you have to interact with it. There's no way around it. Say, for example, if I want to know where an apple is, light has to bounce off the apple and come into my eyes. That interaction is tiny compared to the apple. But now imagine the object is incredibly small. To figure out where it is, you still have to interact with it. But now that interaction is no longer gentle. It's like throwing a bowling ball to find a grain of sand. So the problem isn't that this object is mysterious, it's that you can't look without interfering. You can't find this grain of sand without throwing a bowling ball at it. And that's the quantum mechanics framework. Quantum mechanics begins when measurements can no longer be separated from disturbance. So now hopefully you have an answer to what actually is quantum. If you want to know more, join me in the next video where we go into deeper concepts relating to quantum mechanics.